morning students, my name is Dr. T. Vamshi Prasad. I am working as a assistant professor in BVRIT Narsapur. I teaches you about the applied physics. Today topic is solar cell. In this solar cell, first what is the importance of the solar cell and what is the applications of solar cell? What is the principle behind the solar cell? So what is the difference between the photodiode and solar cell? How the solar cell is constructed in the theory point of view? What is the working principle of solar cell? Okay, and also we have to cross check about the experimental diagram for the solar cell, applications and disadvantages. We will discuss one by one. Generally, the solar cell is a format for PN junction diode. In LED, also the one of the application for the PN junction diode. We are having for so many types of opto component semiconductor devices like LED, solar cell, photodiode, pin diode and avalanche photodiode. So the basic mechanism behind these optoelectronic devices are PN junction diode. So solar cell is also the one of the application factor for the PN junction diode. So LED is also the one of the application for the PN junction diode. Here the main difference for the LED and solar cell is LED emits the light in the form of the pulses. Okay, solar cell is absorption of the light radiation from P to N side. That's why solar cell is said to be it is a photogalvanic cell. Cell means it is an device. It will convert one form of energy to another form. Okay, for example, LED having one input and one output. Okay, so the input is electrical energy, the output is optical energy. In the solar cell, it is said to be one of the one more name is photogalvanic cell. So photogalvanic cell or solar cell is the one which it converts solar energy directly into the electrical energy. Here the input is optical energy, the output is electrical energy. That means energy obtained from the radiation behind the sun. I am saying here solar cell is an energy device. It will convert solar energy, that means energy obtained from the sun directly into the electrical energy. So solar cell is basically PN junction that can generate electrical power when illuminated. So here we have to see here what is the importance of PN junction diode. I am taking here PN junction diode is connected in the forward bias condition. What is the importance of the forward bias condition? The importance of forward bias condition is when an external voltage is connected to the PN junction diode, the potential barrier is altogether eliminated and current starts the flowing. That is the forward bias condition for the PN junction diode. So here in the fabrication purpose, the solar cell is constructed in the PN junction diode that can generate electrical power when it is illuminated. That's why here photovoltaic effect. It is also one of the name for the solar cell. It is said to be photovoltaic effect. So what is the importance of photovoltaic effect is it is a process that can generate electrical current. Here the point is electrical current. That means the current is flowing in terms of milliamperes. Why milliamperes? Means the device is connected in the forward bias condition. In the forward bias condition, the current should be flowing in terms of milliampere. So that's why here photovoltaic effect is a process that can generate electrical current in a photovoltaic cell when it is exposed to sunlight. So our input source is sunlight, the output source is electrical current. That's why here solar cells are usually large area devices. Basically the solar cell having the many more panels, like it is said to be array, panel, devices and grid array. So solar cell having the large area devices typically illuminated with sunlight and are intended to convert solar energy into the electrical energy. This is the one of the key factor for the solar cell. In this slide, solar cell is a photogalvanic cell, and also solar cell, it is said to be photovoltaic effect. So solar cell is formed in the PN junction component, that it is said to be PN junction diode. Okay. Now you can see what is the principle behind the solar cell. So solar cells are based on the principles of photovoltaic effect. This is about the important point for the solar cell. In the LED also, okay, LED is works on the principle of injection electroluminescence. The solar cell, the working principle is photovoltaic effect. So LED solar cell having the same application, but the principle is different, but the operation is same. Both are works under the forward bias condition. So what is the importance of the photovoltaic effect? Here, the generation of voltage across the PN junction in a semiconductor due to the absorption of light radiation. I am saying in the point is the absorption of light radiation. The absorption of light radiation is said to be photovoltaic effect. One more time I am repeating the word. The generation of voltage across the PN junction in a semiconductor due to the absorption of light radiation is called about the photovoltaic effect. So the devices based on this effect is said to be photovoltaic device. Okay, see, I am in the diagram, you can observe here, I am taking the two types of semiconductor components. One is the N-type semiconductor, one is the P-type semiconductor. In the N-type semiconductor, the majority charge carriers are electron. In the P-type semiconductor, the majority charge carriers are holes. Now you can observe here, this is said to be light energy. Okay, so here the light energy is converting into the electrical energy. That means once the light energy is received here, okay, in the N-type semiconductor, electrons, in the P-type semiconductor, the holes are there. So you can observe here, this black color is the strip electrode. So the strip electrode generate about the electrical power. Okay, so what happens here? Here the electrons and holes are recombined with each other. The process is here, it is said to be radiative recombination process. The radiative recombination process, the optical process associated with radiative recombinations are absorption and emission. So here radiative recombination is happening in the solar cell. So you can see the arrow mark. The arrow marks indicates about the electric current is flowing in the device. One more diagram you can observe here. The light energy is incident on the device. We are see here N-type semiconductor and P-type semiconductor. So here the N-type semiconductor, P-type semiconductor both are merged together. It is said to be junction. In the junction we have to observe this is for active region. Active region indicates about the formation of the PN junction diode. One more diagram you can see here. Electron flow movement will be forward direction. The whole movement will be also the one particular direction. Okay. So here this is said to be some energy gap will be forming. Energy gap indicates for the semiconductor device. So in this diagram, electrons and holes are both are recombining with each other. The excess energy will be released. Okay, so the excess energy is here, that is the photon for the radiative recombination process. Okay, you can also see the one more diagram. The solar, this is said to be sun. That means the absorption of light radiation is incident on the solar cell. So here holes will be represented like plus symbol. The electrons are representing like minus symbol. So here the strip electrodes are there here. In the strip electrodes, the electron will reach here. The current will be generating in this device. So here the light will be glowing. The light indicates for the bulb will be glowing. So in the construction point of view, I'm see here anti-reflection coating is forming. So here what is the importance of the anti-reflection coating means to avoid the loss of the incident energy. So in this diagram in this tree diagram, figure 1 and figure 2 and figure 3 indicates about the absorption of light radiation is indicates about the input energy, and the output energy is the electrical current will be generating. So that's why it is said to be photovoltaic effect. Photovoltaic effects means we are taking about the two components, both are sandwiched together, there is a formation of the PN junction diode. That's why it is said to be the generation of voltage across the PN junction in a semiconductor due to the absorption of light radiation is called about the photovoltaic effect. That is said to be principle of solar cell. The principle of solar cell is photovoltaic effect. Coming to the next slide, in the construction point of view, you can first observe the diagrams here. This is the symbol for the solar cell. Okay, I am saying here, you can observe here, this is for one bubble, this is for one more bubble. That means conventional current flow from P to N side. That's why it is said to be PV cell symbol. That means photovoltaic cell. These two arrow marks indicates about the absorption of light radiation. Okay, this is the symbol for the solar cell. One more diagram is sun radiation. This arrow marks indicates about the absorption of light radiation. So here N-type semiconductor and P-type semiconductor. In the N-type semiconductor, I am using the silicon component. The P-type semiconductor also I am using about the component is silicon. Okay, see here N-type semiconductor, electrons will be dominating. The P-type semiconductor, the holes will be dominating. You can observe here substrate base. This is said to be base component. I am also arranging here metallic conducting strip. This white color layers indicates about the metallic conducting strip. What is the importance of this metallic conductor strip is electrons will be jump into in this portion. That means current will be generating in this metallic conducting strip. So according to the definition point of view, the voltage across the PN junction, the generation of voltage across the PN junction diode is approximately 0.58 volts DC power. This is said to be absorption of light radiation. This is said to be the generation of voltage across the PN junction semiconductor device. Okay, so the electron flow will be in this direction. One more point of view, you can observe here, solar cell, it is a crystalline material. Crystalline means I am taking about the silicon. So solar cell consisting of a N-type semiconductor, that is for emitter layer, and P-type semiconductor is also the one of the layer, that is the base. So what is the importance of the base region and emitter is, the emitter portion, it is said to be heavily doped. For the base region, it is a very lightly doped. So the two layers are sandwiched together. That means P-type semiconductor and N-type semiconductor both are sandwiched together. There is a formation of the PN junction. PN junction means the depletion layer will be formed. The depletion layer indicates about the active region. So in the forward bias condition, the depletion layer will be very less. That means the potential barrier will be altogether eliminated. That is about the main point. So the application point of view in this diagram, the surface layer is coated with the anti-reflection coating to avoid the loss of light energy due to the reflection purpose. Okay, and the anti-reflection coating is the one of the key factor for the solar cell. What is the importance of the anti-reflection coating means to avoid the loss of instant light energy due to the reflection process. So the construction point of view, we can arrange the different types of solar cell. Okay, the main point is here the absorption of light radiation. The main point is another main point is the generation of voltage across the PN junction diode. The voltage is approximately 0.58 volts. So similar diagram for N-type semiconductor, P-type semiconductor, you can observe this is for the depletion layer. The depletion layer indicates about the active region. So this is said to be movement of electrons and holes. Okay, the movement of electrons also it is said to be recombination process. Okay, this is about the construction diagram. Coming to the construction diagram, you can see here in consisting of a p-type semiconductor chip on which it is said to be thin layer of n-type material is grown. So when the solar radiation is incident on the cell, you can observe the diagram, this diagram. The solar radiation is incident on the cell, electrons hole pairs are generated. That is said to be main point. So what is the importance of the electron hole pairs means the electrons in the conduction band and holes in the valency band recombine with each other. Recombine means the electron hole pairs are generated in the n type and p region. So the majority of them cannot recombine in the region. So here also the majority means it cannot be continuous process, solar cell. So the majority of them cannot be combined in the region. So they reach the depletion region at the junction. Okay, they reach the depletion region at the junction when an electric field due to the space charge separate them to the device. So here electrons in the p region are drawn to the n region and holes in n region are drawn to the p region. This gives the charge accumulation on two sides of the junction, produces about the potential difference is called about the photo electromagnetic effect on the order is nearly 0.5 electron volts. That means it is said to be EMF, photo EMF. Here what happens mean the charge accumulation will takes on the two sides of the junction, produces about the potential difference or called about the photo EMF. So what is the potential difference means the generation of voltage across the PN junction is nearly 0.58 volts. You can observe here the n-type semiconductor I am using about the cadmium oxide, that is said to be emitter N. The base region is also very thin. So in the p-type semiconductor I am using about the silicon, in the n-type region I am using about the cadmium oxide. So if you use for different layer, the efficiency of the solar cell is mainly decreases here. So that's why it is said to be power conversion efficiency. The efficiency will be different for the different types of material. In the previous slide, I am using about the p-type material as silicon, n-type silicon as n-type metal as silicon. If you use the same material, the efficiency will be higher. If you change the material for the p-type and n-type layer, the efficiency will be goes on decreasing. That's why here the power factor is also the one of the characteristics of the solar cell. You can discuss about the PY characteristic of solar cell also. First we can discuss about the what is the importance of power conversion efficiency. So generally the power conversion efficiency of single crystalline solar cell is in the ranges of nearly 10 to 30% is having about the efficiency. Okay, this is about the one of the drawback for the solar cell. The power conversion efficiency of solar crystalline cell is also the ranges means 10 to 30%. So this is about the schematic diagram for the solar cell. In this diagram we can see about the ohmic contact. Ohmic contact indicates about the electrons will be reach into this region. Why become the electric current will be producing in this way. Okay, this is about the construction side. Basically in the construction point of view, how the solar cell works. This is about the one of the important diagram for the solar cell. Okay, for the generally in the lab purpose, we are the manufacturing about the solar cell into the small component experiment. You can observe here. Generally in the home purpose, we are using about the solar cell arrays and panels. So what is that indicates how it will works on the solar cell, how the electric current will be producing. In this diagram I mentioned about the number wise, what is the serial number 1, 2, 3, 4 and 5. First, the solar cell sandwiched of n-type silicon and p-type silicon. N-type silicon said to be blue, and p-type silicon, it is said to be red. You can see here, this is said to be blue color, this is said to be red color. It generates electricity by using sunlight to make electron hop across the junction between the different flavors of silicon. See here, different flavors of silicon. That means if you use for p-type as silicon and n-type as silicon, its efficiency will be good. If you change p-type as silicon, n-type as cadmium oxide, its efficiency will be slightly changed. Okay, first we can see about the what is the working for the solar cell in this diagram. When sunlight shines on the cell, photons, that means light particles, bombard the upper surface. This is said to be our input source. When sunlight shines on the cell, that means absorption of light radiation is important. Photons, that means light particles, bombard the upper surface. That is said to be point number 1. The point number 2 is the photons, that means yellow bulbs carry their energy down through the cell. That means the energy will transfer into the cell. The photon give their energy to the electrons. Okay, you can see here the photons, see here, these photons give their energy to the electron, that means green, this one in the lower cell, that is said to be p-type layer. The electrons, the point number 4 is the electrons use this energy to jump across the barrier into the upper, the n-type layer escape out in the circuit. In this way, it will escape out into the circuit. So, flowing around the circuit, the electrons make the lamp light up, the light will be glowing here. So, in the generally in one same experiment regarding about the photoelectric effect, the photoelectric effect, the emission of electron from the metal surface, it is said to be photoelectric effect. Here in this circuit diagram, around the circuit, electrons make lamp light up. So, point number 5 indicates about the light will be glowing in this circuit. Here in this region, this is said to be metal strip electrode. When the electron will reach here, automatically the current will be generating, this light will be glowing up. Again, this arrow marks indicates about the, again the current will, the electron will reach here, again electrons whole recombine together, it produces about the electricity here. In this diagram, okay, in this diagram, photons give their energy to the electrons in the lower p-type layer is important. When it is bombarded together, the photons release their energy to the electrons. So, the electrons will carry into the, around these electrons will carry to the metal strip electrode. The metal strip electrode indicates about the current will be flowing in this way. So, here the input source is important, the output source is the power will be generating. So, how the solar cell working in the application point of view? When solar cell panel exposed to sunlight, the light energies are absorbed by the semiconductor metal. In each diagram, the input source is sun radiation. When solar panel exposed to sunlight, the light energies are absorbed by the semiconductor metal. Due to the absorbed energy, the electrons are liberated. The main point is here, the electrons are liberated. When the electrons are liberated, it produces the external DC current. That's why the forward bias condition, the potential barrier will be altogether eliminated, then only current will start the flowing. Okay. So, here the DC current is converted into 240 volts AC current using inverter for different applications. For the construction point of view, we will arrange the different layers of the p-type and n-type layer. So the DC current is converted into 240 volts AC current using an inverter for different application. When these P-type, N-type layers are connected to the external circuit, electron flow from N-type end layer to P-type layer, the current will takes place. So here the electrons that leave the solar cell as current give their energy to whatever is connected to the solar cell. That means, for example, you have to connect about the load. What happens? If you are not connected for load, what happens? That means in the voltage versus current characteristics, we are having about the open circuit voltage and short circuited voltage. For example, in the short circuit current, what is the importance of voltage? If solar cell is connected for open circuit voltage, what is the importance for short circuit current? Once we are calculated for power is equal to voltage into current. That means VOC indicate for open circuit voltage, ISC indicate for short circuit current. At the final point of view, the maximum current is equal to open circuit voltage into short circuit voltage. So in the voltage versus current characteristics, the solar cell is open or short circuited. We have to cross it. Then only we have to calculate about the fill factor. Fill factor will indicate about the what is the efficiency of the solar cell. The point is here, the electrons that leave the solar cell as current give their energy to whatever is connected to the solar cell. Whatever means we are connecting about the load, external load to the solar cell. In the next diagram we have to see that point. Whatever is connected to the solar cell and then re-enter the solar cell. Once back in the solar cell, the process begins again and again. Okay, you can see that point in the diagram in the next slide. See here, how the solar cell working. How does solar cell works in for the part 1 and part 2? You have to observe here. This is for absorption of light radiation. This is for the current. Okay, the absorption of the generation of voltage across the PN junction semiconductor device due to the absorption of light radiation, it is said to be solar cell. In the sphere, these both are recombined with each other. Electrons, hole pairs are generating. This is indicate for metal conducting strip. This arrow mark and this arrow mark indicates about the current will be flowing here. This light will be glowing up. Again, it will reach into this circuit. Okay. So here plus minus both are recombined with each other. That means electrons hole pairs are formed. One more diagram. This is said to be different types of solar cell modules. The solar cell panel array, it is said to be solar cell panel array. I am taking over the one solar cell. This is for several solar cell will connected together. It is said to be solar panel, that is said to be module. One more diagram is several solar panels indicate for the solar cell array. This is said to be completely for solar cell array. In the industry point of view, we can use this kind of solar cell arrays here. So the solar cell arrays and our house to build together different types of power will be generating here. You can observe here in this diagram, sun radiation. This is said to be solar panels. Once the panel will be received about the energy, here point number 1, point number 2, point number 3 and point number 4. Point 1 indicates about the isolator. Point 2 indicates about the DC and AC inverter. Okay. Point 3 indicates about the bidirectional utility meter. So here the power will be generating. Point number 4 indicates about the supplies electricity exported. The electricity will be exposed in this signal. Okay, power cable. See here, we can charge our vehicles also, EV batteries also. The construction point of view, in the house purpose, we are using this kind of technology here. It is said to be solar array and our house purpose. Next, what are the types of the solar cell? Based on the types of solar cell crystals, solar cell can be divided into different types. First one is said to be monocrystalline silicon. Second one is said to be polycrystalline silicon. Third one is said to be amorphous silicon cells. First point, what is the importance of the monocrystalline silicon cell? I am taking about the p-type as silicon and n-type as silicon. Finally, we are calculating about the efficiency of the solar cell. What is the efficiency of the solar cell? First of all, how much power will be calculating in the efficiency point of view. So here, monocrystalline silicon cell is produced from pure material, that is said to be single crystal. Since the monocrystalline silicon is a pure and defect free, the efficiency of the solar cell is higher. If you use the same type of material for the p-type and n-type, the efficiency is very good. If you change the material, p-type as silicon, n-type as cadmium oxide, the efficiency will be decreases. That's why it is said to be mono, polycrystalline and amorphous. Now you can see the polycrystalline solar cell. I am taking about the liquid silicon. Previous one is pure silicon. Now it is liquid silicon. If we use the liquid silicon is used as a raw material, the polycrystalline silicon was obtained followed by the solidification process. That's why it is said to be phase transition module. Okay, so solidification process. The material contain various crystallized sizes, hence the efficiency of this type of cell is less than the monocrystalline cell. For example, if you use for the amorphous silicon, amorphous silicon was obtained by depositing silicon film on the substrate like glass plate. In the construction point of view, we are using about the substrate as the one of the material for the solar cell, that is said to be glass metal. In the flow chart, we can see here what is the comparison for the types of the solar cell. In this chart, we have to observe here material and efficiency in the percentage point of view. I am using about the monocrystalline silicon, the efficiency will be nearly 14 to 17%. If you use for the polycrystalline silicon, its efficiency is nearly 13 to 15%. If you use for the amorphous silicon, the efficiency is nearly 5 to 7%. So, based on these three types of solar cell, the efficiency will be good only for the single material, that is p-type as silicon, n-type is silicon, the efficiency will be nearly 14 to 50%. If you change the material, its efficiency will be nearly 13 to 15%. Amorphous is nearly 5 to 7%. It is very low. Compared to these three numbers, the efficiency will be very high only for the monocrystalline silicon. Okay. Now you can see here. What is the criteria for material to be used in solar cell? The criteria means what is the silicon, what is its energy gap value for silicon. In the silicon, the energy gap will be nearly 1.1 electron volts. You can see here, must have the band gap from nearly 1 electron volt to 1.8 electron volt. It must have the high optical absorption. Why? Become the solar cell, the absorption is very important. That's why it is up to the absorption of light radiation. It must have the high optical absorption. It must have the high electrical conductivity. The generation of voltage across the PN junction, it is said to be electrical conductivity. That means the power will be calculated in the voltage and current. The raw material must be available in abundance and the cost of metal must be very less. That is the criteria material to be used in solar cell. Must have the band gap value is very important, and also the what is the absorption, optical absorption is also very good, and also the electrical conductivity. If it is used for the raw material, the cost of metal will be very less here. Okay. Now what is the solar cell importance application point of view? In this slide, you can see here what is the advantage of solar cell, disadvantages and uses of solar generating system. So solar cell is generally no pollution associated with it. It must last for a long lifetime process, and also the maintenance cost is also very less. That's why it is said to be no maintenance cost. Disadvantage of solar cell is it has the high cost of installation. The efficiency is also very less for the solar cell in the disadvantage side. During the cloudy day, the energy cannot be produced, and also at night we will not get the solar energy. Clouding day, we are having the summer season and winter season, monsoon season. Here the input power is very important. Once the input power is continuously observed, the electrical power can be generated. Once the input power will be goes on decreasing, the electrical power are also decreasing it. That's why it is said to be cloudy day. The energy cannot be produced, and also at night we will not get the solar energy. That is about the drawback for the solar cell. What is the uses of solar generating system? It may be used for charge batteries for the EV vehicle. It is used in light meters. It is used to power calculator and wristwatches. Very important. It can be used in spacecraft to provide about the electrical energy. In the washing machine also, we are using about the solar cell, power calculator and wristwatches, spacecraft to provide about the electrical energy. This slide indicates about the VI characteristics of solar cell. This is said to be experimental diagram for the solar cell. In the lab, we constructed about the solar cell. Okay, you can observe here. This diagram indicates about the voltage versus current characteristics. The x-axis indicates about the voltage. The y-axis indicates for the ampere. The voltage I am keeping here maximum power voltage. This is said to be maximum voltage. This is said to be open circuit voltage. Okay, you can see here the maximum power can be calculated for voltage versus current, and also maximum current. This is said to be maximum power point. You can observe here in this slide. This peak indicates about the power versus voltage curve. Two graphs are there here. One for the voltage and current, one for the power and voltage. Power, maximum power is calculated by the voltage into current. That means open circuit voltage into short circuited current. The formula is here. P is equal to VOC into ISC. ISC indicates about the short circuit current here. VOC indicates for open circuit voltage. What is the importance of the open circuit voltage and what is the importance of the short circuit current? How we are calculating about the power here? So power is equal to voltage into current. Okay. This diagram is also indicate for fourth quadrant factor, one of the characteristics for the solar cell. You can also observe here area. Area is equal to maximum power voltage into maximum power current. This is said to be PV curve. This diagram indicates for the IV curve. X-axis indicate the voltage and y-axis indicate for the current. Finally, we are calculating about the maximum power point. You can see here VI characteristics of solar cell, open circuit voltage and short circuit current. Open circuit voltage. When the solar cell is open circuited, that is not connected to any load. Very important. Once again I am repeating the point. Open circuit voltage indicate for V suffix OC. When solar cell is open circuited, that is not connected to any load, the current will be at its maximum. That means the current value should be approximately 0 and the voltage across the cell is maximum. That is said to be open circuit voltage, indicate for VOC. In the diagram we have to see here, the current will goes on decreasing, voltage value will be increasing here. That is said to be open circuit voltage. Open circuit voltage indicate for the current value will be 0, voltage across the cell is maximum. Now it is short circuited current. Short circuit current is when the solar cell is short circuited. Previous one is solar cell is not connected to any load, I value is 0, V it is maximum. Now short circuit current indicates about when solar cell is short circuited. That means the positive and negative leads connected together, both are connected together, positive and N leads are connected together. The voltage across the cell it is minimum. Now it is completely 0 and the current flowing out of the cell reaches maximum. That means the current value should be very high. That is said to be short circuit current, indicate for I suffix xa. Short circuit current indicate for V value is 0, I is maximum. Open circuit voltage indicate for current is 0, voltage is maximum. Now power can be calculated as maximum power point is equal to P is equal to V into I. This formula indicates for the maximum power point. There is a one particular combination of current and voltage for which the power reaches its maximum value at maximum power point and maximum power voltage. In other words, the point at which the cell generates the maximum electrical power, this is shown at the top area of the green rectangle. In the diagram, it indicates about the maximum power, that means area is equal to. This is said to be maximum power point, indicate for MPP. Therefore, the ideal operation of the photovoltaic cell, that is panel, is defined to be at the maximum power point. This is said to be maximum power point. So maximum power point is equal to V into I. Once the power is calculated, we have to calculate about the one more element is fill factor. So the fill factor is the ratio of actual maximum obtainable power to the product of the open circuit voltage and short circuit current. This is the key parameter in evaluating the performance. Fill factor is a measure of the squareness of the IV curve. You can see here. The efficiency of the solar cell is very important for the solar cell. Just now we have to see about the monocrystalline material, polycrystalline material, amorphous material. The efficiency of the monocrystalline material is nearly 15 to 17%. So it is defined as the ratio of maximum power, electrical power output to the radiation, power input to the cell. It is expressed in terms of percentage. Now you can see about the just small example for solar cell. It is considered that radiation power on the earth is about the 100 watts square meter. Hence, if the exposed surface of the solar cell is the amperes, then the total radiation of power on the solar cell will be 1000 ampere watts. Substitute this here, the efficiency of the solar cell is expressed as efficiency, the symbol is neta, maximum power divided by maximum power input. You can see here the maximum input power of the earth is nearly 1000 amperes watt. Here the formula wise. Coming to the conclusion point of view, what is the difference between the solar cell and photodiode? Solar cell is the photovoltaic effect principle and it also said to be photogalvanic cell. Both are fabricated the PN junction diode only. Now you can see here PN junction photodiode can be operated under the photovoltaic condition similar to that of a solar cell. The current, voltage, characteristics of a photodiode under illumination is also similar, but there are few differences are there about the solar cell and photodiode. For example, photodiode, only the narrow wavelength range centered at the optical signal wavelength is important, whereas the solar cell, high spectral resonance over a broad solar cell wavelength range are required. So the important figure of merit for the photodiode is the quantum efficiency. That means number of electrons hole pairs are generated by the incident photon. That's why it is said to be radiative recombination process, photodiode. More number of electrons and hole pairs are generated by the incident photon. While the main concern for the solar cell is power conversion efficiency. That means power delivered to the load per incident solar energy. So photodiodes are mainly designed to be operated as the reverse bias condition, whereas solar cell is designed for the forward bias condition. The main point for the photodiode and solar cell is works under the principle of the forward bias. Photodiode is works on the principle of the reverse bias condition, quietly opposite. And also about the size is very important. The size, you can see a size. Photovoltaic effects are bigger, more sizable than the photodiodes. Power handling capacity for the photovoltaic power capacity is also very more sizable than the photodiode. Application point of view, photodiodes are used as the sensors. Now photovoltaics are used as a transducer. Both points are similar here, but sensor is also the said to be energy converter. Energy converter means it will convert one form of energy to another form. So photovoltaic cell also it is said to be transducer. Transducer is also about the energy device. It will convert one form of energy to another form. So basically transducer will convert light energy into the electrical energy. That's why photovoltaic effects is used as a transducer. So sensor used as a photodiode. So photodiode operates in the third quadrant and solar cell operates in the fourth quadrant. That is the VA characteristics of the solar cell. Okay. So this is about the lecture of the solar cell. These are about the references for the solar cell. Okay. Okay. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.